Good morning, 7th standard. So, in your previous videos which I have sent, you would have had an introduction about what is light, the properties of light. So, in that, you would have come across one particular property which is called as reflection. Reflection means the bouncing back of a light when it falls on a surface which is able to reflect it. Okay, it's like a polished surface, mostly a mirror. So once when reflection takes place, you have to know the property, the terms associated with it, and the important outcome of reflection is your laws of reflection. So hope you all watched it. So I just want to give a recap on them, and then we'll move on to the next topic. So the first one, whenever a ray of light, here we will just draw a single line and put a arrowhead to indicate that is a ray of light. Okay, so whenever a ray of light falls on a polished and a smooth surface, you all know polishing means it is something which is very shiny. Okay, so we use that, and it should be smooth surface. Then what happen, in which angle the particular ray of light is going to fall, in the same angle but it in the opposite side, it's going to be bouncing back. That is called as your reflection. So here you can see AO. So this line AO is your incident light. Similarly, this line OP is your reflected ray. OB is your reflected ray. Now what I'm going to do, I have to draw a 90-degree line between them, which I call as your normal ray. I call as your normal line. Okay, so I'll explain you how it works. Okay, consider this as your plane surface. It's a very plain polished surface. Now a ray of light falls on it. So in which angle it is going to fall, the same angle it will be thrown back. So this line is called as my incident line. In which direction it's going to come, that direction I'll draw my arrow, and in which direction it's going away, I'll put an arrow in that side. So now draw a 90-degree line. You all know what is a 90 degree, so no, so I'm going to draw a 90-degree line. So this line is called as normal, this is called as your incident, and this is called as your reflected. Now the angle between the incident and the normal, it's called as your angle of incidence. The angle between the reflected and the normal is called as your angle of reflection. See, just for your understanding sake, I have made it quite bigger, so it will also be in the same direction. So from this you can understand the angle of incidence and the angle of reflection will be equal. The angle of incidence and the angle of reflection will be equal. So the point where you are able to see your incident ray is called as point of incidence, and this one is called as your point of reflection, and the surface where all these is going to happen is called as, it's called as your plane of incidence and the plane of reflection, the surface. Okay, this surface, this particular surface, okay, this surface is called as so the entire surface, the entire plane, the surface in which all these is going to happen will be called as is your, this entire plane where it is going to happen is called as your the plane of incidence, and that is the plane of reflection. So laws of reflection. So the laws of reflection states you can easily identify the incident ray and the reflected ray will be equal. That is, the angle of incidence and the angle of reflection will be equal. Suppose a ray of light is incident at an angle of 30 degree. Therefore, what will be your reflected ray? It will be also 30 degree. If the ray of light is incident at an angle of 47 degree, therefore the reflected ray will be 47 degree. And what you can infer from this, you can see the incident ray, the reflected ray, the normal, everything is inside one particular plane. They are not in different surfaces, they are going to be in the same surface. So this is called as your laws of reflection. Based on this, since we are studying about a plane surface, here we are going to experiment about your plane mirrors. So the normal mirrors in which you everyday morning you look at yourself, comb your hair, adjust your dress, that is called as your plane mirror. Okay, that is called as your plane mirror. So before videos we saw what is a plane mirror, some of the characteristics of the image obtained in a plane mirror. So now you must be clear what do you mean by object and an image. You must be clear by what do you mean by object or image. So if you are going to stand in front of a mirror, you are going to be the object, and you're going to see yourself, your reflection on the mirror, which is called as your image. So this you all clear up to this. Okay, so object and image. So in the plane mirror we saw how does your image will be. So we know it will be erect, that is it's going to be upright, it will not get tilted to an angle or it will be upside down, nothing. Whatever may you are going to stand, it will show you the same manner. And one more thing, it has lateral inversion property, which means if you are going to move your right hand, you will observe it as your left hand. So only that inversion property we have in your plane mirror. So now let us see the ray of image of an extended size object. So first I have sent an video which is for your point sized object. Point size means it's going to be a dot size. Now the case is for an extended size. Extended size means imagine I'm going to keep a pencil, something which is much bigger than a point. Now how the image is going to be formed. You better, before going into this, you just think of, if you're going to take a pencil and place it on a mirror, in front of a mirror, how does the pencil will look like? Will it be the same, or will it change its direction, or there will be a change in size? Will it be smaller or bigger, or it will be uh, 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 what happens to its size, its shape, its dimension? And does anything happens to your pencil in case? No. Whatever you keep in front of your plane mirror, it is going to be the same. So now let us see how it is going to be produced in a theoretical manner. Whatever we are able to see, we have to prove them in theoretical manner. So now let us see how it is working. So this is your mirror. Okay, whenever you draw a mirror,